Okay, so one last step before we move on to our discussion. So the last step now is to compare with theory. So comparison with theory. And I'll make that a heading 3, I think. So according to the theory provided, the equation for the relationship should be, and what was it? It was in here. It was t equals 2 pi square root m over k. So let's write that in here. So let's insert an equation. T equals 2, and then backslash pi gives you pi, and then backslash square root, and then backslash frac for fraction, and it was m, and then I go forward arrow to go to the bottom, and k, and the suggested k value for this spring was, what was it? It was 34 newtons per meter. I'll do this as an equation as well. 34 nm, and then shift 6, -1, so newtons per meter. Shift 6 always puts you up into superscript. That's a little symbol that looks like a little up arrow or a little hat. Okay. Our equation is, well, it's this. And then we can say we can rearrange the theoretical equation to be, let's do it like this. And let's take this whole thing out and write just m, and then 2 pi what's the best way of doing this? Two over, well, actually I'm going to do this in a way that hopefully will make a little bit more sense than that. So you can see here that t equals 2 pi square root m over k. It looks a little bit like this, and we have t is equal to something times root m. We know that k is a constant and pi is a constant, and so t is equal to some constant times the square root of m divided by some square root of some constant. So the theoretical theory says it should be t, whoops, t is equal to 2 pi square root frac m over 34, right? So square root of m over 34 is the same thing as square root of m over square root of 34. So we can just make it, that's equal to, oops, let's get out of that square root first. That's equal to 2, sorry, I'll do it like this, 2 pi over square root 34 times square root m. So now you can see in this new form, this number here should be equal to this number here, and there's no y-intercept expected, so this number here should actually be 0. But if you look carefully at it, this number is somewhere between -200s and +400s, so 0 is included there. So let's make this comparison now. So let's figure out what 2 pi over square root of 34 is. 2 times pi divided by 34 square root is equal to 1.077, it should be. Equals 1.077 times square root m. So our gradient of this is smaller than the theoretical gradient, which does not lie within our experimental uncertainty. That's the first thing we can say. Our y-intercept is slightly larger than the expected y-intercept of 0, but 0 is within our experimental uncertainty. Okay, so now we've made a comparison with theory. So we have got this is our experimental equation, and we have compared it with what theory says it should be. In other words, we've compared this gradient of 2 pi over square root 34 with our number 0.93 plus or minus 0.07. They are close, so maybe we should make a point of saying that is close, but still smaller than the theoretical gradient. It's close to, I should say, but still smaller than the theoretical gradient. So now we've done everything we need to do to get a merit on our report. The last step is going to be the step that might give us excellence. So I'm going to just write the heading for that here, and then we'll do that in a separate video. So let's make a heading 2 here. This is going to be the discussion. Alright, I'm going to remove this extra line that I added.